Good morning.
Good morning.
How is everyone? I hope that everyone who needed additional access to our last lecture was able to watch the video because it was recorded without any problems, and I posted this on the YouTube, uploaded this to the YouTube.
Thank you.
Could you able to access that?
Yeah. So I have a question. So the homework, I think homework 9, a lot of things we did not work on here. And could you reopen again? Because a lot of my classmates too, a lot of that problem we did not know.
Oh, did you mean the equations?
Yeah, because the
So I don't remember. I need to go back to the person. Did it reach the due date?
yeah, the due date is yesterday.
Actually, yes, probably I can give the extension, but at the same time, I covered already all required examples for that session. And we cannot say that we did not have this or did not cover that, because this is just a combination of algebraic methods and trigonometric formulas to solve these problems. So yeah, I will probably be open to give about maybe maximum 2 more days, but not immediately right now, because I need to visit a person site to do that.
Okay, thank you.
Okay. Okay. So I definitely can show 1 or 2 more equations if you need, and you can feel absolutely free to ask me for about certain problems which caused some kind of headache. Do you have any particular problem in your mind? Guys, I need to know what I have to do. Do you need any help with any equation from section 3.3? Yes? No?
Yeah, it's, I think maybe you can pick up the question about 57 to 80, either one.
Let me write it down. 1 second, please. Can you repeat, please, one more time?
On the questions, maybe around 57 to 80.
But I like to ask you to choose particular one. You are giving me entire spot, but I like to ask you to be more specific. Let's say such and such problem or such and such problem.
Okay, maybe 74.
74?
Yeah.
Okay. 74. Let me copy that on my paper. It is on page 207. And problem number 74 was 2 cosine squared theta minus 7 cosine theta minus 4 equals to 0. And we need to solve it for all angles in 1 revolution. So this y on the side, I'm going to write that semi-closed interval, which is written in the textbooks as an inequality. Are you talking about this problem? Guys?
Oh, yes.
Okay. Let's analyze what we have in this particular problem. First of all, this is a trigonometric equation. And I already repeated that several times when we have equation which is slightly longer than, let's say, on page number 206, you need to ask yourself the following question. In this problem, do you have same angles under symbol of trigonometric functions? Yes? No? No. What is the angle under each cosine? Is it theta?
Yeah.
Yes.
What I'm asking, do we have same angle at both spots here?
Yes.
Yes.
Second question, do we have same functions?
Yes.
Yes, we have. It doesn't matter if one here is with the first power, the other one is in the second power, but it is same cosine. It is same cosine at both spots, cosine of theta. Yeah, at the beginning here in the first term, it is 2 times cosine squared of theta. In the second term, it is cosine theta multiplied by -7, but it's the same cosine again, once in the first power, one in the second power. Do you have in your mind any equation from algebra, not from trigonometry, in which you had your unknown in the first power and in the second, and the highest power was second? What was the name of that type of equation?
Quadratic?
Absolutely, yes, it was a quadratic equation. But this problem number 74 is not a quadratic equation, it is a trigonometric equation. But at the same time, can we say that it has a shape or form of regular quadratic equation from algebra? Does it remind us quadratic equation structure?
Yes.
Yes.
And this is why we call that type of equations as, listen carefully, quadratic equation with respect to cosine theta. This is why we can immediately have a substitution. Which letter from Latin alphabet you like to use for cosine theta? You can choose from A to Z. Tell me about your letter. X,
B.
Y, Z, T, M, and which one?
B.
B. Okay. Then look what I'm writing. I wrote, let cosine theta be B, then my equation is actually 2 cosine squared theta minus 7 cosine theta. Oops, excuse me, I started writing same thing again, I really apologize. 2b squared minus 7b minus 4 equals to 0. 2b squared minus 7b minus 4 equals to 0. And you can solve this equation using any method for quadratic equations. You can use quadratic formula method. You can use completing the square method. You can use factorization method if it can be factored. I already, in my examples, used quadratic formula method. It was in problem number 64. Problem number 64 I solved with you previously, I think on the last lecture. And this is very close problem. If you look at the third line, it is also a quadratic equation only with respect to sine theta. So it is a cousin of that problem 74. This is why I'm saying that I showed all needed examples for this material. So I'm going to solve this to find value of B. In problem number 64, I used quadratic formula. Here I will try to use, let's say, factorization. I like the order 2 times -4 is -8. In the middle, I have -7. So Negative 8 can be factored in many different ways, but to find values which in the product give me negative 8, I need to choose that combination, which when numbers being added will give me negative 7. And these numbers are negative 8 and positive 1. Because again, how did I get this negative 8? I multiplied 2 by the last number, which is negative 4. It is negative 8 as a result. And after that, I looked in the middle, discovered negative 7. This is why I'm choosing that combination of factors for negative 8, which in the sum will give me negative 7. So this is why I'm going to rewrite my equation in different form, in different visual form. It is same equation, only instead of 3 terms, I got 4 terms. And now I will be grouping. I will combine first term with the second and third with the fourth. So this I even show with arcs. From first 2, I am factoring out 2b. Again, this is what you learned in Algebra 120. So this is what I'm getting, starting my grouping. 2b, b minus 4, plus 1 times b minus 4. b minus 4 is common factor. I'm factoring this also, and this what I'm getting. This is already the end of factorization. I factored this trinomial. After that, I can use zero factor property. Again, I'm just demonstrating you right now how I used factoring for this quadratic equation with b. If you do not want to do that, go ahead and use quadratic formula method. So after that, I will be using two here. For these 2 factors, I will be using so-called zero factor property, because if the product of 2 parentheses gives us 0, I can make each of these factors equal to 0 and solve separately for b. This is why I am breaking this into 2 equations, and each equation will be solved for b. b minus 4 is 0, 2b plus 1 equals to 0. From the first one, I am getting b equals to 4. From the second one, I am getting 2b equals to negative 1. Divide both sides by 2, and I'm getting b equal to negative 1/2. This is the end for quadratic equation with b in it, because I found 2 values of b. But it is not the end of my equation, because I need to solve my equation for theta. This is why I will return to theta as my unknown. It means if b is equal to 4, it means cosine theta should be equal to 4. And I try to solve this equation where I can see cosine theta should be equal to 4. But this equation, even though quadratic equation has its solution b equal to 4, trigonometric equation where cosine theta equals to 4 does not have any solution, because cosine of any angle cannot be greater than 1 and cannot be less than 1. So in this case, I'm going to write that that particular equation has no solution. Or if you don't want to write this as a word, you can write theta belongs to the empty set. Theta belongs to the empty set means the set of numbers is empty. There are no numbers in it. It means no solution. This is an international symbol for the empty set. This circle crossed by short line. I am moving to the second one. In the second one, I have cosine theta equals to -1/2. And I'm completely satisfied with this value because yes, cosine theta can be equal to -1/2 because -1/2 is a number between -1 and +1. And now I am going to sketch small trigonometric circle, which is a unit trigonometric circle. I know that in this circle, cosine is equal to the x coordinate of the endpoint on the terminal side of the angle. So cosine of any angle is equal to the x coordinate. This why on the x-axis, I will find the point for which x is equal to -1/2. You can see it is on the left side from 0. And I will restore perpendicular so that it will intersect that circle at these 2 points. And I'm going to connect these points with the center of this circle. And now I can show 2 angles for which cosine will be equal to -1/2. One angle will be from the second quadrant, and it is perfectly matching what I learned before, that cosine in the second quadrant should be negative, and the other angle is in the third quadrant. And I'm going to find right now both angles. Which angle in the first quadrant has cosine equal to +1/2, ladies and gentlemen?
Pi/3.
Absolutely correct. That pi/3, it is a reference angle. That angle which we have in the circle in the second quadrant, can I say that it is pi minus pi/3?
Yes.
So it is true. Pi minus pi/3, which is 2 pi/3. And it is my first solution for theta. That angle, which is in the third quadrant, is it equal to pi plus pi/3?
Yes.
That's it. Pi plus pi/3, which is 4 pi/3. That's it. And now I just will write what I have for solution set. First angle is 2 pi/3. Second is 4 pi/3. And I'm completely done with that problem. You can see in this problem, we had quite many algebraic steps because we first solved quadratic equation. And after we found solutions of quadratic equations, we returned back to trigonometry. And this is quite typical for all these problems. I will randomly right now give you some advices for some problems, but I will be very quick. On the same page, again, I just randomly will grab some problems to give you some advices. For example, 76. Can you look at 76, please? What do we have here? We have same angles, but we have different functions. What would I do if I were you? I would replace, please, you can write this comment on your paper. It is problem number 76. I would replace here cosine squared theta by 1 minus sine squared theta. it will let me get rid of cosine function. I'm getting in this problem, instead of cosine squared theta, 1 minus sine squared theta, which will have sine function in it. And again, I can simplify adding, distributing 4 on the left, adding like terms, and getting another quadratic equation with respect to sine. If you look at number 75, I would get rid of sine squared theta here, replacing this by 1 minus cosine squared, for example. If you look at problem number 70, it has tangent and cotangent. I would get rid of cotangent, replacing this by 1 over tangent, and after that multiplying both sides by tangent, and I will get, in this case, the quadratic equation, which will have tangent squared. It is actually tangent squared of theta equal to 1. And I will continue solving this equation, etc. So you can see here, we have many, if you are solving problem number, let's say 67, can you look at problem number 67? Are you there?
Yeah.
What would I do? Can you see in this equation, you have sine of negative theta? I would apply first property of sine, because sine is an odd function. I will grab this minus and take it to the front of that sine, which has another minus there. Minus negative will be positive. So basically this equation can be easily converted into cosine theta equal to sine theta. But this right now is not having second powers of cosine and sine. What would you do? I really recommend you to divide both sides of that equation, which is cosine theta equal to sine theta, up to you. If you like more cotangents, divide both sides by sine theta. If you prefer to deal with tangents, divide both sides by here, cosine theta. And it will be converted in very easy equation like tangent theta equals to 1. And solve. You can see again, we have here many equations when you again can ask yourselves if you had same angles. If you said yes, look if you have same functions and try to use trigonometry to come to another equation where you will be having same functions and start solving that equations. Quite often, your new equation will look like a quadratic equation. In this case, first solve quadratic equation, find values for the solutions of quadratic, and after that, come back to trigonometry and solve it trigonometrically. That's it. Again, now, unfortunately, I cannot solve every single equation in this section with you because I, again, showed quite many examples and they were good enough. You, again, need to be very good friends with formulas, with values, and definitely we apply here algebra a lot. Okay. What I'm planning, okay, just 1 second, please. Definitely, I will check what I have on Pearson, on my math lab. And if the due date, can you help me again? The due date, was it yesterday at 11:45?
Yeah, at homework 9.
Okay.
Thank you.
And this is are you asking about homework number 9?
Yes.
And this is homework number 9 about trigonometric equations.
Yes.
Okay. I will probably give, no, not probably, I just accidentally used that word probably. In this case, I can give you the extension for today and tomorrow up to 11:45, but after that, it will be closed.
Okay.
Is it clear to everyone?
Yes.
Yes.
Yeah. Yeah.
Okay. I'm going right now to move to another section. And another section is 3.4. Very interesting section. Yes, but it has different topic. And it also deeply depends on your good relationship with formulas and values. This why, if you open that section, it starts on page 210. On page 211, you can see again old formulas which we covered long time ago. It is just reminding you that look at these formulas, we will be using them. You have here many good examples in the textbook which are completely solved to give you some ideas what to do. I went on page 216 where we have problems on 216 and 217. And again, today I will randomly choose some problems and I will be solving these problems in which we have so-called identities, more specifically, trigonometric identities. There are many problems. I physically would not be able to solve all problems from this section, definitely, but together with examples which are already solved in that section as in the theoretical part of this section, plus problems which I'm planning to work with today, in my opinion, should be good enough to help you to succeed with this material. But again, there is important also think what I have to remind you again. You need to perfectly know all properties and formulas and values of trigonometric functions, and you need to be really good friend with algebra. So you can see there are quite many important conditions to succeed. You need to actually be sure that you answered positively on each of these questions, like, do you remember everything what you learned in 120 algebra course? Yes. Do you know all these values, properties which we learned in this class? If both answers are yes, I think you should succeed in this material. If any of these questions considers answer no, you need to first restore what you have to know for this material and work with these problems. So can you please write the topic? And the topic is trigonometric identities. Trigonometric identities. And I definitely will be showing some examples, but at the same time, I will let you choose some problems which you like to see being solved during today's lecture, and you can ask me to solve these particular problems. I, at the beginning, need to say a few words about trigonometric identities. In math, we have many problems like identities. Identities is a word which has very close relationship with word identical. In Latin word, it is identicus. It means same thing, equals to, this equals exactly to the other piece. In these identities, we have trigonometric expressions. They, at the glance, can talk absolutely different. I'm talking about the left side and the right side. But between left side and the right side, we have an equal sign. It means that even though they look different, but mathematically they are equal to each other. You need to choose one of sides and you need to simplify this side. And finally, you can stop only when you, as the result of this simplification, are getting an expression which is absolutely equal to the other side expression. Let me show you an example. For example, problem number 20. It says, establish each identity. In different textbooks, you can see different sentences. They can sound different, but they deliver the same message. If you see establish identity, or prove identities, or verify identities, for all these modifications of the sentences, it has the same meaning. Prove it that it is true. For example, here in problem number 20, I have secant theta times sine theta equals tangent theta. So first, I copied that identity. Now, you need to choose one of sides, left side or the right side. I really recommend you, I'm not saying you have to, or I am forcing you to do that. I'm saying I am recommending you to choose that side to start with. If that side looks more complicated to you than the other side. This is why I'm asking right now, all of you, which side would you like to start with the left side or the right side?
The left.
Left. Write down about your intention. Look what I wrote down. I wrote down, this is an abbreviation, LS. Do you understand that it stands for the left side?
Yep.
And now I critically look what I have on the left. Is it secant theta times sine theta?
Yes.
Can I replace secant theta by 1 over cosine theta?
Yes.
Yeah.
Guys, can you be a little bit more active, please? So I am writing down that it is 1 over cosine theta times sine theta. Now let's use algebra. So, which means what? I need to multiply that fraction, which is 1 over cosine theta, by sine theta. Is it going to be 1 times sine theta, which is sine theta, over cosine theta? Yes? No?
Yes.
Yes.
Now, according to what we already learned a long time ago, sine theta over cosine theta, is it tangent theta?
Yep.
Yes.
That's it. Is it what we had on the right side?
Yes.
Yes.
I'm talking about right side in the original problem. Yes, which means what? Yes, we are done because we proved that identity. We established or we verified this identity. This is why, to show that this is the end, look what I'm going to do. And this is an international symbol. Can you see? I placed that small square completely filled inside. This means the end of proof. In other words, that we are done. Is it clear?
Yeah.
Can I move to another problem?
Yeah.
Yes.
Excellent. Okay. What do you think about problem 35? Does it look enough complicated?
Yes.
So can you please start copying that? We will solve it. But I will let you start this problem because I need to check attendance. I don't want right now to look at the site. It will take more time. I will be reading your names. And as soon as I'm done, I will join your company to solve that problem. So secant to the 4th power of theta minus secant squared theta equals tangent to the 4th power of theta plus tangent squared theta. Secant to the 4th power theta minus secant squared theta equals tangent to the 4th power theta plus tangent squared theta. So you can start without me. Where is my roster? And I will work with you as soon as I check your attendance. So today is 23rd of April. So Bryce.
Here.
Gracia.
Here.
Alexia.
Here.
Hannah.
Here.
Andrew. Dimitar.
Here.
Benjamin.
Here.
Jesus.
Here.
Ariana.
Here.
Axel.
Here.
Desiree.
Here.
Lila. Lila. Bhaktima.
Here.
Jessica.
Here.
Ivuna.
Present.
Devin.
Here.
Valeria.
Here.
Excellent. Okay. Let's talk about our problem. What do we have here? We have 4th power of secant and 4th power of tangent. We have 2nd power of secant and 2nd power of tangent. Which side would you like to start with, left or right?
Left.
Is it just one person's opinion?
Left. Yeah.
Left. Okay, write down left side. And what do we have on the left side? Is it a difference of 4th power and the 2nd power of the same function?
Yes.
Yes.
If you had in algebra, let's say a to the 4th power, I'm going to write on the side, a to the 4th minus a squared. And if you like to factor, can you factor out a squared?
Yes.
Does it mean that we can factor out secant squared theta?
Yep.
What would be left in parentheses? Can you help me, please?
Secant square theta minus 1.
Absolutely beautiful. Yes. And now let's see how we can connect these two expressions, which is secant squared theta. The second is secant squared theta minus 1 with tangents. Now I'm going to ask you a very important question. Go back to all formulas which we learned. Did we have any formula there in which we had both, and secant and tangent.
Yes.
Which one?
Tan squared theta plus 1 equals secant squared theta.
Excellent, because it is not a good reply. It is awesome to go to that, back to that formula. I'm going to write this formula on the side. So tangent square theta plus 1 equals secant square theta. So, first of all, look at this first secant square theta. Can I replace that secant square theta by what I have in this formula for secant square?
Yes.
So let's do that. So, which means instead of first secant squared, I will write in parentheses tangent square theta plus 1. So this is replacing secant square theta. But I have in the second part, I had secant square theta minus 1. Okay. Can you please look again at that formula which we had right here? Tangent square theta plus 1 equals to secant square theta. What if we have in our mind algebraic properties, which are, first, if we like, we can add to both sides or subtract from both sides the same number or expression, first. Second, can we move from one side to the other side, changing the signs? Yes.
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 What if we, up to you, you definitely can subtract 1 from both sides from that formula, which we had here on the side. But I decided to grab this 1 and move it from left to right. Should I change the sign?
Yes.
Yes.
So, which gives me what? That tangent square theta will be equal to secant square theta minus 1. And where did it come from? It came from that old formula. Is it correct? Guys?
Yes.
So can you look at what we had in our problem in this parenthesis? Is it secant square theta minus 1?
Yes.
Is it actually tangent squared?
Yep.
So look what happened. In this step, what we see, all sequences disappeared, and instead of sequences, we have tangents on the scene. But in my original problem, I did not have parentheses. So what I'm going to do, I'm going to distribute right now, dropping parentheses. So this way, I need to multiply both tangent squares by each other. If I multiply tangent squared theta by another tangent squared theta, is it tangent to the 4th power?
Yes.
If I multiply 1 by tangent squared, is it tangent squared?
Yep.
Is it what you should get?
Yes.
Is it the expression which exactly matches what we had on the right side in the original problem?
Yep.
That's it. Can I place that small square?
Yes.
Yeah, yes. And I'm done with that particular problem. Did you understand the nature of these problems?
Yep.
Again, you should prove that this is a true identity, because it says establish identity, which means there's two sides, they can look completely different, but mathematically, left side and right side are equal to each other. So you need to start with one of sides. You need to take several steps And you are stopping at that moment when after these steps, you are getting the expression which completely matches the other side of that identity. That's it. This is the process. Yeah, but it is much easier to describe in general that we have to do that, we have to do this, but it is much more difficult to concentrate. Definitely, it is absolutely possible, and many people succeed doing this type of work with one condition. You need to perfectly know what to do with algebraic steps, and you need to perfectly know how to apply and in what kind of moment to do that, all trigonometric formulas and properties and values which you learned before. I can continue solving more problems. You can choose your problems. You are welcome to do that. I can only maybe recommend you some of problems. Are you, for example, okay with problem 58?
Could you also do 45?
45, definitely I can. Would you like to do that problem?
Yeah.
"45 secants theta cosecants," same thing, theta, plus sine theta over cosine theta equals 2 tangent theta. Is it that problem which you asked me about?
Yes.
Okay, let's discuss. First question is, which side, according to your opinion, is more complicated than the other side?
The left one?
Okay, again, is it just one person's opinion?
Left one.
Left one.
No.
Left one?
Yeah.
Yeah.
Okay,
Yeah.
but I'm going to ask you why, let's say, again, I agree with you, but I like just to push you to give me a little bit more feedback, more explanation. Why, in your opinion, the left side is more complicated than the right side? Can we have someone who can explain it to me? Guys?
There's 4 different variables.
We do not have different variables. We do not have variables here at all because it is not an equation. We can talk about parameters, but it's okay. But we have said theta, 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 theta. Maybe you were talking about different trigonometric functions?
Yeah.
Yes, this is why I slightly polished your answer. Yeah, we have here and secants and cosecants and sine and cosine, too many, 4. What do we have on the other side? Is it just one single tangent?
Yeah. Yeah.
What is more complicated, to have 4 different or just one same function? Definitely, it is true that left side looks more complicated than the right side. So does it mean right now that it is everyone's opinion to start with the left side?
Yes.
Yep.
Let's do that. Let's write down LS, left side. First, think about relationship between tangent and these functions on the left. We do not have here secant squared. We do not have here cosecant squared. We have both here in the first power. At the same time, we have sine in the first power. We have cosine in the first power, right?
Yeah.
So, does it mean that we need to do something applying trigonometric formulas, trying to come to certain form which will be equal to tangent theta, right?
Mhm.
Yes.
Can you look at the left side's second term? What do we see there? Is it a fraction which has on the top sine theta? On the bottom, it has cosine theta.
Yes.
Is it a formula for tangent theta?
Yes.
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 Store it in your mind. Let's look at the first fraction. Does it have secants, theta and cosecants?
Yes.
Can we quite easily, applying easy formulas for both, convert them into combination with sine theta and cosine theta?
Yes.
What about secants theta? Is it 1 over cosine theta?
Yes.
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 On the bottom, we have cosecants. Is it 1 over sine theta?
Yes.
Write it down. And look what I'm getting already. I'm already having tangent in that step. Now, at the beginning, is it a fraction divided by fraction?
Yes.
Can we apply algebra? Because we know any division of fraction by fraction, it can be replaced by the multiplication, right?
Mm-hmm.
Only, don't forget, we need to multiply by the reciprocal of the second fraction.
Oh, okay.
So write it down. Is it what you wrote down?
Yeah.
Yes.
If you multiply these two fractions, do you get sine theta over cosine theta?
Yep.
Is it now a fraction which actually is equal to another tangent theta?
Yeah.
Yes.
Yes.
Okay. So, which means you are actually getting tangent theta plus tangent theta. Tangent theta plus tangent theta, are they like terms?
Yes.
What would be a result of that addition here?
2 tangent theta.
Is it everyone's opinion?
Yeah.
Yes.
Yeah.
Is it what we had originally in our problem on the right side?
Yes.
Are we done?
Done.
Yes.
Yes.
And
Yeah.
honestly, was it a difficult problem?
No.
No.
So which means what? Don't panic. Start solving these problems and you can discover that actually it is much easier than you thought at the beginning. So we already solved 3. I can solve more. We will choose the problem right now. And after that, I will declare a 5 minutes break. And we will continue after that. Is it okay with you?
Yes.
Yep.
I again deeply recommend you to look at problem 58. It is quite interesting problem. Are you okay with that problem?
Yes.
Okay, let's copy that problem and after that you can start your break. Sine theta times cosine theta over cosine squared minus sine squared equals tangent theta 1 minus tangent squared theta. Okay. So right now it is 11:10. Can you please be back at 11:15? Okay. Is it okay with you?
Okay.
Okay.
Yes.
Okay. Thank you. Okay. Can I continue?
Yep.
Okay. Let's precisely look at both sides of that identity in problem number 58. Ben, what would you do starting with which side, left side or the right side? Ben? Okay, there is some problem. I don't know why. Okay. Ariana, which side looks more complicated to you? Guys, are you there? I am calling your names.
Yeah.
I am Ariana. Which side, according to your opinion, looks more complicated than the other side?
For me, I think it's the right. A little bit, but not too much like the left.
I absolutely support your opinion. Yes, because definitely, if we compare all 6 trigonometric functions, many people like you, like me, we would say that sines and cosines members of sines and cosines family are easier for us than, let's say, tangent, cotangent, and specifically, let's say, secants and cosecants. I think majority of people will have this opinion. Do you understand? This why, is it okay with all of you if we start solving this problem with the right side?
Okay.
Yes.
Yes.
Thank you for your permission. In this case, instead of LS, please write RS, R and S. And now let's analyze this further. Both sides, they are represented like fractions. Do you agree?
Yeah.
On one side, we have only sines with cosines. On the other side, we have only tangents.
Yeah.
But in that tangents are hiding sine and cosine.
Yes.
Yes.
And probably everyone understands what I mean under hiding, because it means if we like, we can replace each tangent by the ratio of sine to cosine. Is it correct?
Yeah.
Let's do that, because in our benefits is to get rid of tangent, and instead of tangent, to have something which will have sine and cosine in it, because we have them on the left side. So this will be our first step. What we have on the top, tangent theta, not anymore. It will be sine theta over cosine theta. What do we have in denominator on the right? 1, okay, I'm copying 1. But instead of tangent squared theta, can we write that it will be sine squared theta over cosine squared theta?
Yes.
And now I am getting 4 levels instead of 2 leveled form. I got 4 leveled form, but it is absolutely okay, because I am going to simplify the bottom to get single fraction, and after that I can replace division of 2 fractions by the multiplication as we did in the previous problem. Okay, let's do that. Sine theta over cosine theta. On the bottom, is it 1 minus that fraction?
Yep.
Yes.
If we need to subtract this fraction from 1, Should I think about least common denominator?
Yeah.
Yes.
What would be least common denominator? Don't forget that this one I all the time can write like 1/1, right?
Cosine squared theta.
Absolutely correct. Cosine squared theta is the least common denominator. This is why I'm writing this down, cosine squared theta. And instead of 1, can I write that it is cosine squared theta over cosine squared theta?
Yep.
Yes.
And look what we can get in this case. I'm going to show it to you right now. This is what you get.
Okay.
Sine theta over cosine theta on the top. On the bottom, it is a fraction which has cosine squared theta minus sine squared theta over cosine squared theta. Do you understand everything what you see, where it is coming from?
Yes.
Yes.
And now, what do we see here? It is a fraction divided by another fraction. Right now, it is time to convert this into multiplication. So it will be. I don't want to keep 4 leveled form. So times cosine squared goes to the top of the second fraction. Cosine squared theta minus sine squared theta is in denominator. Now it is a fraction times another fraction. You know what? We can cancel something right now. Look what we have on the bottom of the first fraction. Is it cosine theta in the first power?
Yes.
Yes.
Can you see what you have on the top of the second fraction? Is it cosine squared?
Yes.
Yep.
Theta. If you had, instead of cosines, a at the bottom of the first, a squared on the top of the second, could you cancel by a?
Yep.
Yeah.
Only instead of a here, we have cosines. So look what I do. I crossed cosine, and I crossed that second power. And now what is left? On the bottom of the first fraction, I have 1. I can even write 1 if you like. It is not a necessity, but if you like to make it visual. Can now I multiply?
Yes.
And I am multiplying fraction by fraction. What should I have on the top? Should I just multiply sine by cosine of theta? So sine theta times cosine theta. On the bottom, should I multiply 1 by this difference?
Yes.
Is it matching what we originally had on the left side of this problem?
Yep.
Can we say that we're done?
Mm-hmm.
Okay, so place that good looking square. So we are done with that problem.
Okay.
Okay, so I am moving down more and more. Are you okay with, just 1 second, please, let me see. Let's say 67. I just randomly choose the problem. If you disagree, give me your problems. Guys, can you please reply that we will not waste our time?
Yeah.
67 is okay.
Okay. Let's copy 67. Thank you. Copy and think about one of sides which you like to start with. What kind of advice can you give me about one of sides? Please. Which one should I start with? Ivona? Ivona? Nobody replied to my question. I see your names on the side. Ivona, can you hear me? No reply. Okay. Dimitar, what would you tell me to do?
Well, I would start on the left side.
Is it everyone's opinion?
Yep.
Actually, mine too. You gave me really good advice. And let's see what we have on both sides. The right side looks very beautiful. It just has one term. It has cosine, but it is cosine squared, right? On the other side, we have fraction plus 1 in this fraction. On the top and the bottom, we have tangent squared. But do you understand that finally we need to come to the expression which carries only cosine squared? Yes?
Yes.
Yeah.
What would you do with this tangent?
Use an identity.
On the left, we are starting with the left side. We need to take the first step. This is why I'm asking, what are you planning to do with these tangent squares on the top and the bottom of that fraction?
Change it to cosine.
I cannot change it just to cosine. Can I change it to actually sine squared theta over cosine squared theta?
Yeah.
Yes.
Let's do that. And on the top and on the bottom. Okay. And this, what I have right now, and I am going to simplify each numerator and denominator separately, building LCDs. And if you can look at both fractions, you can see that for top expression and for the bottom expression, least common denominator should be cosine squared theta. Do you agree?
Yes.
Okay, let's do that. So, and on the top, we have cosine squared theta, and on the bottom, we have cosine squared theta. Look, I even wrote this in that way. And now I'm going to complete the tops of each of these fractions. 1, is it cosine squared over cosine squared?
Yes.
It will be on the top, cosine squared theta minus sine squared theta over cosine squared theta. On the bottom, I will have cosine squared theta plus sine squared theta over cosine squared theta. And now I will convert this division into multiplication by the reciprocal. So it will be cosine squared theta minus sine squared theta over cosine squared theta times cosine squared theta over cosine squared theta plus sine squared theta. And now I have a fraction times another fraction. Can I cancel cosine squares on the bottom and on the top of each fraction?
Yep.
Yes.
Cross them out. You are left now with cosine squared minus sine squared of theta over cosine squared theta plus sine squared theta on the bottom. But precisely look at the bottom. What do we have here? Is it a sum of cosine squared theta and sine squared theta? Do we have a proper formula for that sum?
Yes.
And what it is equal to?
1.
Fine.
Yes, guys, it is equal to 1. So replace it by 1. If we divide by 1, can we ignore in the next step that 1?
Yep.
Is it cosine squared theta minus sine squared theta? Let's stop here if I did not have this identity because I already simplified. But in my identity on the right side, I have a different expression. This is why I cannot stop right here. Can you see on the right side, we have only cosine squared?
Yes.
Does it mean that I need to do something with that sine squared theta?
I think so.
Yes.
This sine squared theta, if we replace this by something with cosine squared, is it 1 minus cosine squared?
Yes.
Yeah.
So minus 1 minus cosine squared theta. I don't have sine squared anymore, but I have minus in front of parentheses. Can I drop this parenthesis? Be careful,
Yes.
you have a minus in front of parentheses, which means it will be cosine squared here
Mm.
You know what? I think this problem in problem number 67 has a typo because if you check all these steps, you can see it is 2 cosine squared theta minus 1 because we did not. Now, 1 second, please. It is, no, if we had typo, because this is what we actually got for our fraction. But can you see in this original problem, right here, we had plus 1?
Yeah.
This why, please add 1 to each of these steps because we mainly, I will show it to you. We worked with this fraction because it was more complicated part. Please add 1. And you can see I added 1 to each step in this problem, plus 1, plus 1, plus 1 everywhere. Please do that. And now look what we got at the end. Is it 2 cosine squared theta minus 1 plus 1?
Yep.
Can we cancel them? Is it what we should have?
Yep.
saying that we are done?
Mm-hmm.
Place that square. Can I move to problems on page 217?
Yeah.
Okay. I'm removing this paper. Are you done with that?
Yes.
Okay. So I'm now on page 217. Which of these problems looks quite complicated to you? Maybe 97?
Okay.
Okay. Yes.
Does it look nasty enough?
Yeah.
Why? Can you see it has natural log, it has absolute values, blah, 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 right?
Yeah.
Are you okay with 97?
Yes.
Okay.
Yep.
Okay, so let's write it down. So page number 217. Number 97. And we will be working again absolutely in the same manner because we are going to compare left side with the right to see which one looks more complicated. Okay, natural log, absolute value, 1 plus cosine theta plus natural log. Definitely, you need to know formulas for logs to solve this problem, not just trigonometric formulas. 2 natural log, absolute value, sine theta. Which side would you like to start with?
Left side.
Left.
Okay, I absolutely support your opinion. So please write down left side. But before I start solving, I need to make one comment because I'm looking right now at the names of participants. And unfortunately, some people not mature enough, and I hope that they will watch that video because they left and they are not interested in actually getting explanation during the regular communication between me and students, because I definitely can answer your questions because it is not just a recording. It is a conference where you can ask me some questions, when you can get my answers. And I definitely, as a teacher, will take care of that people who left earlier. So let's look at the left side. And the first thing what I'm going to do, I will apply the property of one of formulas or properties of logs. If you have log of A plus log of B, and it is on the, here, on the right side of the paper, can we replace by one single log? If you have a sum of 2 logs and both logs have the same base, it is natural log, base is E. How can I replace that by one log? Can you please help me? This is what I'm talking about, guys. In these problems, in these textbooks, they assume that if you passed previous class, you have to remember important formulas and properties from previous level. It is a log of the product. It is log of A times B. If you do not know that formula, you will never be able to solve this problem. This is why I can replace now left side in original problem, which has log of that expression plus another log, by the log of the product. And this is the log of the product of 1 plus, I accidentally forgot to write theta in the first parenthesis, I apologize. It is 1 plus cosine theta times 1 minus cosine theta. Now, I need to apply another algebraic formula. If you have A plus B times A minus B, what it is equal to, ladies and gentlemen?
A squared
A squared
plus 2.
No. It is A squared minus B
Minus B
squared.
squared.
And we actually reviewed all these formulas when we covered chapter 1. It was a review. So again, please review all these formulas because in trigonometry, we actively use algebra. So, which means we are applying already the second algebraic formula so far. We did not use any trigonometry. So it will be natural log of A in our case is 1, 1 squared is 1. B is in our case cosine theta, which will be minus cosine squared theta. So we have natural log of absolute value of 1 minus cosine squared theta. And only right now, I'm going to use trigonometry. What can I write down instead of 1 minus cosine squared theta? 1 minus cosine squared theta equals to what?
Sine squared theta.
Right. Sine squared theta. Now, I will continue, and now I again will be using algebra. So I just used a little bit of trigonometry, and I'm back to algebra. Natural log of sine squared theta, I all the time can write like natural log of sine theta with absolute value squared. Do you understand that? Guys, yes, no?
Yes.
And now I need to apply another logarithmic formula because it is log of x squared, log of the power. I am not right now naive again to ask you that question. I'm just going to remind you that formula. But do you understand that you need to review all these formulas? This is what it is equal to. Natural log of x squared equals to 2 natural log of x. We used here already 3 major and 1 not really major formula from algebra. So it will be 2 natural log of absolute value of sine theta. Is it what we had originally on the right side?
Yes.
Yeah.
Are we done with this problem?
Yes.
Uh-huh.
Yes, we are done. I hope that you understand that we actually solved quite many problems from that section. I will even count how many examples. 1, 2, 3, 4, 5, 6, 7. not all the time we can afford this kind of things to show 7 problems from certain section. Besides that, in your textbook and theoretical part, you have, let me see how many examples. 8 examples solved in this section. So you have plenty, really many examples to analyze, to see how they are being solved. I'm talking about examples demonstrated by me today during our lecture, and 8 additional examples solved in the textbook. Plus, I think if you are serious about succeeding with this topic, you need to review important trigonometric and algebraic formulas. And after that, start solving these problems. I'm going to post this assignment again on my math lab. And I am planning to start the next section the next time. Is it fair to make that kind of statement?
Yep.
Okay.
Thank you. I have about 2 more minutes and I can answer. Maybe I can give you some hint for certain problems. You can ask me any question so far. I'm ready to answer. Would you like to ask me about something?
I don't have any questions.
Okay, I'd really like to help you with one of problems here on page 217. I'm talking about, let's say, about problem number 82. Even though on the left side we have sines and cosines, and on the other side we have secant, sine, and tangent, if I were you, I would probably start with the left side here because we have cubes. And starting with the left side, if I were you, I would simplify first sine cube plus cosine cube, because this is matching algebraic formula a cube plus b cube, and a cube plus b cube is equal to parenthesis a plus b, close parenthesis, open new parenthesis, a squared minus ab plus b squared. So, and after that, we'll continue also taking more steps. And I would do probably the same thing in 81. In 79, I would start with definitely left side, treating this like difference of 2 algebraic fractions. So you need to think about LCD right away. LCD on the left will be cosine theta times sine theta. Please use algebra to simplify the tops and use trigonometry to simplify this more, etc. So you can see again, in all these problems, we have a mixture of algebra and trigonometry all together. I hope that you learned what you have to do with these problems. Again, I will try to post this on YouTube. I don't know if Zoom is going to help me to do that, because sometimes it is sabotaging that. But again, if you don't have, if you need some additional information, watching same video again, the video of the same lecture again, you can do that a little bit later, because I need to teach another class. So, and so far, I will be a little bit busy. So with your permission, can I end today's class?
Yeah.
Yeah.
Everyone have a nice, beautiful day. Stay well.
Thank
Be
you.
careful. Okay. And
Thank
the
you. Bye.
best
Bye.
to you and your families.
Bye.
Bye.
Yeah.